This week we are going to work with the VDDT software. Let's go ahead and start the VDDT. You started it with the start menu. The first thing to do is to connect to the correct database. And you just go down to File, Database, and then you navigate to the database that you are going to work with. And the database that you are working with in this exercise is located on BBLearn in this week's folder. So I'm going to connect to my database. It's called 18VDDT_V1. It's an Access database, and then I open the database. And we're going to work with this 1811-260 simplified model. So there it is. So I think you can go through the lab exercise sections A, B, and C pretty easily, but I'm going to start on section D, where you're going to have to start modifying your VDDT diagram. So we start off with this diagram where we have an early sagebrush, mid-successional sagebrush, and a late successional sagebrush, and you'll learn more about these in the lab section, earlier sections A, B, C. And then in section D, you're actually going to modify this diagram a little bit. So make sure you finish A, B, C sections in the lab document before you get to this point. So under section D in model assumption number 1, it tells you that we need to modify this 3-box model into a 4-box model with the classes that are described. Class 1, herbaceous, less than 5% shrub cover; B, mid-open, 5 to 15% shrub cover; C, mid-closed, 15 to 25% shrub cover; and late-closed, greater than 25% shrub cover. So we're going to go ahead and do that. So you're going to need to add and subtract some of these successional boxes here. So we're going to go to the diagram. Let's start by deleting that class C. It's pretty easy to do. It's gone. It's all right. I think it's gonna go away. Oh, there it went. Okay, just had to push some buttons a few times there. And then, so we're gonna then add C and D. And the reason I deleted C was that I wanted it to label it a little differently. So we're gonna add new class. We're gonna call it C. It's gonna be mid. Let's see. It's gonna be a closed. It's gonna be a mid-developed. And it's going to be a closed because B is mid-open. And then we're going to add another one, new class, and that's going to be D, and it's going to be late, and it's going to be closed. So there we have our boxes. That's pretty easy. And then you're going to have to fix them so that they have the correct number of years in them. And you can see there under model assumptions 2, it says that the first box A is going to last for 5 years. So you just double click on the box and then go in and change the end age to 5. And then you save that. And then the next one will be 6, 2, and it's going to last for 10 years. So that's going to be will be 15 then. And then the next box will start at 16 and last for 10 years to 25. And number 4 will be starting at 26 then. And 99 is okay. I guess the assumption there would be that it stays in that box unless something happens to it, unless we have a disturbance. So we've fixed our boxes. The next step then would be to go in and look at the transitions. So this one is correct. So we go from A to B after 5 years. stays in 10 years. After 15 years from the beginning, we go to C. So B goes to C, to a mid closed, and then we go to D, which is a late serial closed. And we're going to have to change that. So the box there is going to be D. So then we created that successional transition there. And then you'll have to add your disturbances. So we can start in box A. We'll start with a wildfire scenario. We're going to have replacement fire scenario A. If you look under point 15 or point 5 under the model assumptions, we're going to set the probability for wildfire to point 0.001, and that's the wildfire. And then here later I'll show you that you can also add, if you want to add a new disturbance, for example the prescribed fire, you can add a new disturbance, and I don't see anything called RX fire, but we could call that optional 1, but I'm not going to add that yet. You can do that later. Guess we need to, looks like I have to add something since I added that line, so I'll add that. Call it optional 1, but I'll put probability 0 for now, and I can change that later. So, and that's also going to go to A. There we go. So we'll keep doing that, get our transitions entered. We have for class B, we have a transition that also goes to box A. Everything returns to the early successional after a disturbance. Just change the probability there to 0.001. Do the same thing for C. We're going to add a new replacement fire with a probability of 0.001. Oh, it's going to go to A. And for D, we're also adding a new standard placing disturbance, probability 0.001, and goes to box A. So there we have it. And of course, you know, you can add management and other insects and whatever disturbances you think you have in your system. So basically we have created our model there for the wildfire scenario. So the next step would be to run the model. I'm going to go run. I'm going to start with fixing up the settings. And here, according to the instructions, we'll use the default number of time steps is how many years we're going to go out in time. We'll run it out 100 years, which is a fairly long time considering management scenarios. Number of cells, it just means how large the area is going to be. We'll put 100 there as well. And simulation, we'll repeat it 100 times because there is a stochastic component in this. There's that probability of fire. You need to run it more than one time to get standard deviations or variance around your runs. And this could change. You could, you know, you could play around with this and change these to maybe run it more times and see if the standard deviation changes or not. But we'll use 10 for this example. And for this type of simulation, we'll use the historic range of variability. Initial conditions. Let's use what was thought to be the initial condition, an assumption under model assumptions under 7 there. We had 5%. These are actually inputs from the Caribou-Targhee National Forest. So we had 5% in A, 35% in B, 20% in C, and 40% in D, which is the late successional. So these were inputs from the forest itself. The total area represented was 36,500 acres, so we can put that in as the representation. And this should add up to 100% area, so that all looks good. Under options, we'll just leave the defaults there for now, and for output we'll browse for folder, and for this example I'm just going to put it in my temp folder, but the best for you to do is actually to create a folder on your computer where you want to save this information. So maybe create a folder that's called scenario 1, scenario 2, scenario 3, and scenario 4, and then you'll actually run a 5th scenario as well. But I'll put it in CTemp for now. For summary reports, I'd like to look at my state classes, which is A, B, C, and D. I'd like to look at transitions. Maybe not every time step, maybe every 10 time steps is enough, since I'm running 100 time steps, and I'll also look for the reports every 10 time step. And I'll minimize the size. And then you can go ahead and run this. And VDDT runs real quick. It's a very easy software to use. I think it's already done. And then you can go to your graph. So run graph results. And we can look at the classes, which are those state classes. Let's look at the line graph, and let's look at time step 1 through 100. And I don't think we need to select anything in the options, so let's just go ahead and look at that. I want to look at all of them. Hit OK. And there they are. So these are my results. So it looks like if I'm running the wildfire scenario in the Caribou National Forest with this example, I'm going to have very little early successional. I have 40% to begin with, and it's going to disappear. For my mid developed class, which is the 5 to 15% cover, is also going to become very low. My C, my mid-developed, is also going to decrease, and it looks like everything is going to end up in the late closed, because there is very little fire in this system. So that's how you can run VDDT. You can now go in and modify your prescriptions and add this optional prescribed fire and put probabilities to that, and keep going with the exercise. And what you can do, actually, now when we made all these modifications, I suggest that you save this diagram as a different model. Otherwise, your other model will disappear. So you can call this either simplified 2, or you can call it something else, like my model, or 4-box model, or something like that. Maybe I'll call it 4-box. Just give it a new name, because then you can go back to your old model, and you can also look at this new model that you created.